Before we begin, please open up EasyC version 4 for Cortex. Hello future programmers! Today I'm going to teach you how to program a basic operator control for a VEX robot competing in a competition using EasyC version 4 for Cortex. Now maybe you might be asking, what is operator control? Operator control is the time during a competition match in which the driver controls the robot with a joystick controller. Now, let's start programming. First of all, what do you see when you open up EasyC version 4 for Cortex? You see File, Edit, View, and other words at the top. This is the drop-down menu. You will mainly use this to save, open, and download your projects. Under, you will see some icons. These are basically shortcuts to the drop-down menu above. Under that, you will see a mini window called Function Blocks, which we will talk about later. Remember this. Next to this mini window, you'll see a tab called Start Page. Under this tab, you will see New Standalone Project, New Competition Project, and Open Project. If you already have a project, you can click Open Project to browse through your documents and open a previous project. But if you are using EasyC for the first time, you will probably not have any projects. So first, because we are programming your robot for a competition, click on New Competition Project. A window will now open up. In this window, make sure the circle next to Field Control Competition Project is selected. If you select Time Competition Project, you will need to wait 20 seconds every time you want to test your robot, but we don't want that, so make sure Field Control Competition Project is selected. If you wish, you may want to change the team number to whatever you wish. Now click OK. Look back at the start page again. Some new tabs have appeared. Right now we only need to focus on operator control, so click on the operator control tab. What do you see under the tab? These shapes with words are blocks. Notice how the blocks mostly go down in a line. This is how this type of programming works. Your program starts at the begin block, goes through the other blocks in the program, and ends at the end block. Everything between these blocks is what will tell the robot what to do. Picture this, instead of the robot reading down the line, you are the robot, and the line is the street. You are walking down the street. Now, look at the block labeled while. See how it branches out away from the main line? This block interrupts the program, and when the program reaches this point, the robot starts reading the line branching off the main line before it continues. It's like if you're walking down the street and there's an alley. You go down the alley first before you come back to continue down the street. This while block is called a while loop. It's called this because while something is happening, the program will keep repeating this loop before continuing down the main line. Since you want the robot to be able to be driven throughout the whole operator control, you'll want all of your programming to be in this while loop. Now it's time to go back to that mini window called Function Blocks. Remember where that is? Notice that there are some folder icons now. What you will need is the joystick folder icon. Double click on that icon. All the words in this are called functions. All these functions involve using the controller to control the robot. Now let's start with the drive, or the wheels, that will move your robot around. Do you see the first four functions under the joystick folder icon? They say Arcade 2 motor, Arcade 4 motor, Tank 2 motor, and Tank 4 motor. Arcade is for controlling your entire drive with one of the analog sticks on your controller. Tank is for controlling one side of your drive with one of the analog sticks, and the other side of the drive with the other analog stick. The 2 and 4 motors are simply for how many motors you have for the drive. Now, the basic robot will have 2 or 4 motors for the drive, but let's use 4 motors. As an example, let's do Tank 4 motor so that the left analog stick will control the left 2 motors, and the right one will control the right 2 motors. Left click and hold on the Tank 4 motor function and drag it between the 2 blocks with brackets on them. You will find these next to the while loop. This area between the brackets is where you'll place most of your functions. Once you've placed the Tank 4 motor function in the while loop, a window will pop up. If you're using 2 joysticks, click on the first drop-down box and choose which joystick you want to use for your drive. In our case, you'll just want to make sure that the joystick is 1. Next, make sure that the left channel is 3 and the right channel is 2. These are the vertical or up and down numbers you see on your joystick controller next to the analog sticks. Look at the left front motor of your drive on your robot and look for the number port it's plugged into on your robot brain. Change the number in the box under the words left front motor to what number that motor is plugged into. Do this for all 4 of your motors. Motors either rotate in one direction or another. One direction is 0, the other is 1. In the window, for each motor, you'll also see invert direction. Invert direction means to change to the opposite direction. This is the direction the motors will move in. Normally, you'll want to change one side of the robot to 1 because these motors are facing the other way, so they'll obviously rotate in the other direction. So take either side, left or right, and for the rear and front motors of that side, change the invert direction number from 0 to 1. Now, sometimes, depending on how you've built your robot, this might not always work properly the first time, so you'll want to test to see if you've inverted the correct motors. At the bottom of the window, it has a comment box. This is just to remind you what that function is for. If you wish, you can change this to drive or something else. Click OK at the bottom of the window. Next, we're going to program the other parts of the robot. Now, we're going to take a look at the other parts of the controller. Those tank and arcade functions are only for the analog sticks, but what if you want to use the buttons on the joystick for maybe an arm or your intake or gripper? The buttons on the joystick are digital buttons, unlike the analog sticks. So, let's look at the functions under joystick again. Look below the tank and arcade functions. Go down the list until you see joystick digital to motor. This is what we want to use because we want the signals to go from the joystick digital buttons to the motor to make it rotate. You'll need one of these blocks for each motor that you want to be controlled by a digital button. Let's start this section by programming the arm. Start by left-clicking, holding, and dragging the joystick digital to motor function between the brackets from before, just right under the tank 4 function you dragged in before. Another window will pop up, and in this window, you see a somewhat different setup. You see the same joystick and channel numbers, but after that are two sections called forward direction and reverse direction. This is basically a more complicated version of the invert direction boxes from before. Before we talk about this, let's go back to the channel number box. This is the same thing as the drive, except it has 5, 6, 7, and 8 for the channels. Channels 5 and 6 are the buttons at the top of the joystick, and channels 7 and 8 are the 8 buttons on the front of the joystick. Change this to whatever you wish. For a simple robot, you'll want to use channel 5 or 6 for the arm and the gripper. You might need to do some testing just like the drive, but for this, instead of changing from 0 to 1, you change the buttons from 1 to 2 or 2 to 1. Under the forward section, you see a box labeled button number. This is what I mean by 1 and 2. For channel 5 and 6 buttons, there are 2 buttons. One button will rotate the motor one way, the other button will rotate the motor the other way. For now, leave it the way it is and go down to the box labeled motor number. Change this to whatever motor port one of your arm motors is plugged into. Then comment on this function block if you wish, just like the drive, and click OK. You'll need one of these joystick digital to motor function blocks for each motor on your arm. For the motor on the left side of your arm, you'll leave the directions the way they are. For the right side of your arm, you'll want to change the buttons to the opposite. For the forward direction button, you'll want to change it to 2, and for the reverse, change it to 1, but only for one side of the arm. This is how you invert the arm motors. You switch the 2 button numbers. Like I said before, you'll want to do some testing for this to make sure that you have the right motor inverted. Now the gripper is the exact same thing as the arm, so program the gripper the exact same way, except put in the motor ports that your gripper motors are plugged into, and change the channel to another channel of your choice. Now once you finish that, look back at the drop-down menu at the top of the EasyC window. Do you see Build and Download? Left-click on this, and some options will drop down. First, you'll want to compile the project to change your program from words to numbers so that your robot brain can understand it. Click Compile Project. Click OK once you see the window that says the project was successfully compiled. If it doesn't say this, you've probably done something wrong with your program. If this happens, go back and see if you made any mistakes. Once your project is compiled, go back to that Build and Download drop-down menu, and this time, click Build and Download under Compile Project. Now, take the orange programming cable and plug one side into a USB port on your computer and the other side into your robot brain. Make sure it's properly plugged in. Click Yes on the window that says, the hex file was successfully built. Would you like to download the program? If it doesn't say this, do the same thing you do if compiling the project fails. Now, once you click Yes, another window will pop up and you'll see a bar with a green square at the end. Wait for it to appear at the beginning of the bar, and slowly move towards the end. Once this is complete, click OK. Congratulations! You have successfully programmed the operator control for your first competition robot using EasyC version 4 for Cortex. If motors are inverted, go back to the program and invert necessary motors. If you've missed anything, you can always replay the tutorial and listen to it again. Thank you for listening to the beginner's tutorial on EasyC version 4 for Cortex by Mathew Nguyen.